Hi, my name is Andrew McLaren. Today we're going to talk about redox reactions under basic conditions. I have a very long video going over redox reactions generally speaking, which are normally under acidic conditions. But today we're going to go over the main idea about basic conditions and how it changes this, as well as talk about two example problems in depth. And you should be able to go through these problems by the end of it. So the main idea with basic conditions is very closely related to the other steps where you're still trying to balance the matter and atoms for the half reaction and the charge as well, so that you can relate the two sides through their electrons. But basically, instead of using H plus now, we have to look at there being OH minus in solution. In basic conditions, if you remember Kw, as the concentration of H plus goes down, the concentration of OH minus goes up. So we can think of this as not really having any H plus in solution. There's hardly any in solution when we have basic conditions, and there's much more OH minus. So it is much more likely to be reacting with things present in the solution. That's the main idea behind what we're doing here. But how that works is that you need to add OH minus to both sides, and then you're going to make some water with the H plus and OH minus, because when you put those two things together, you get H2O. So you can just do that to a 1-to-1 mole ratio. And then that's going to make some water, which you're going to have to cancel out appropriately and just kind of account for that. It's going to be different for each problem depending on how much water already was present and how much water now is present, and canceling those out between the two sides so there's no like spectator ions of water. And then you're left with, in this case, some OH minus on one side and some water on the other side. And if you were to look at this reaction, it should be balanced in terms of the charge. It should be balanced in terms of the matter as well. And so it's very similar to what we're doing with H plus conceptually, but you end up typically just doing as the last step to like cancel out the H pluses because those aren't really present now. So we've got another example problem here, and it's worked through all the way. I did this with one of my students that I was tutoring, and I had this reaction. We were trying to figure out what that would look like in basic conditions. And so for me, it's very much the same normal procedure that I would do with like the H plus and like H2O. So you gotta add some water to both sides, then you gotta add some H plus, and then you gotta add electrons. So that's pretty standard. I think I go through that pretty in detail in my last video. Though I don't know if I talked much about numbering these. I've done that with a couple students recently, and that helps them keep track of what numbers go where in the final equation. But when you get to the basic part, you need to look at this like we talked about in the main idea. There's some H pluses. We don't want to have H plus in basic conditions. We want OH minus. So to keep things balanced, because this is a balanced equation right now, we need to add the same thing to both sides. Now that we have OH minus written in the formula, that's good because that's the major species that's present, not H plus. But we had to cancel out a little bit of water here because there was 4 waters now and 2 waters. And so you cancel out those like spectator ion waters, and you get essentially a new reaction, but it looks very, very similar. If you see the acidic condition reaction, you probably, if it was a multiple choice test, would be able to figure out what the OH minus was just by like moving it to the other side and accounting for the change in water. But be careful with the water. That's probably the area that people mess up if they try and cut corners. So here's a multiple choice problem that I had with another student. I did slightly different color coding, but we have the 3 main steps there that you go through for acid conditions. And you go through that procedure. You can see I kind of numbered those as well. And then what we need to do is we get to this part where we need to add OH to both sides, keeping the equation balanced. And that will create some water that you're gonna have to cancel out, and you'll have to figure out how much water is left over. But for the most part, these other things are at the same ratio as beforehand. So just be careful with that, and you should be okay. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page, and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.